Hello, welcome to video lectures. I am Karanam Assistant Professor, Vijayanagara College, Hosapete. And this topic is on torsional stress and deformation theory. Now, to begin our understanding of this topic, we shall understand what is a torsional pendulum. When I consider a circular disc which, when being suspended vertically by an inextensible wire, then the disc acts as a pendulum and is called as torsional pendulum. Now you are observing that the wire is being suspended from the point of suspension and the disc is being suspended freely and the disc is rotated. The disc is suspended vertically and is rotated in a horizontal plane. Whenever it is being rotated in a horizontal plane so as to twist the wire, the various elements of the wire undergo shearing strains. As it undergoes shearing strains, it produces a restoring couple which produces the oscillations. If the angle of the twist at the lower end of the wire is theta, then the restoring couple is c theta, where c is called torsional rigidity. If this couple, which when acts on the disc, produces it in an angular displacement, therefore, from the law of conservation of energy, the total energy of the system remains constant or it is conserved. That means the energy is neither created nor destroyed. It remains constant. Then what is the total energy of this system? The total energy of the torsional pendulum is nothing but the sum of potential energy plus kinetic energy. Then what is the potential energy and what is the kinetic energy and what is that amount of the kinetic and potential energy? To determine, first we shall understand what is the potential energy of the system. The potential energy is nothing but the restoring couple through an angle theta, and that can be obtained as the summation of all such twists produced over one complete length of the wire in producing torsional oscillations. And that is nothing but that it can be obtained by summation of all such values. Summation means integration. Therefore, we have to integrate all such values from 0 to theta, the value of the moment of the couple with respect to d theta. That means with respect to theta. That means integration of 0 to theta, moment of the couple into d theta. That is equal to integration of 0 to theta. Moment of the couple is nothing but restoring couple. That is equal to c theta. That is given by c theta into d theta. Now to integrate this component, c is a constant and integration of theta d theta, it is similar to that of integration of x dx. Integration of x dx can be written as x to the power of 1 plus 1 by 1 plus 1. That is equal to x to the power of 2 divided by 2. That is equal to c theta square divided by 2. Therefore, the potential energy of the system is given by half c theta square or c theta square by 2. And however, the kinetic energy of the disk is given by half I omega square, where I is the moment of inertia of the disk and is nothing but the product of the mass and the square of the distance from the axis of rotation. And I omega is called as the angular velocity and is nothing but rate of change of angular displacement. The total energy of the system is given by c theta square by 2 plus half I omega square, which is always a constant. That is, total energy remains constant. In other words, the total energy is given by c theta square by 2 plus half I omega square, that is equal to a constant. Now, we have to differentiate this expression with respect to time. That means with respect to t. Time means with respect to t. Now, to differentiate this component, that is equation 4, first we have to take c by 2 common, that is outside. Differentiation of theta square, differentiation of x square, differentiation of x square with respect to x. In other words, first we shall understand what is the differentiation of x with respect to x. Differentiation of x with respect to x is 1. Similarly, differentiation of x with respect to t is given by dx by dt. In the same way, differentiation of x square with respect to x is 2x. However, differentiation of x square with respect to t is given by differentiation of x square is 2x to the power of 2 minus 1, and differentiation of x with respect to t is given by dx by dt, that is equal to 2x into dx by dt. That in the same way, differentiation of theta square can be done, that it can be written as differentiation of theta square is 2 theta and differentiation of theta with respect to t is d theta by dt. Therefore, differentiation of theta square with respect to t is 2 theta d theta by dt plus the next term is given by half I omega square. Here if I take I by 2 common, then we get omega square. Differentiation of omega square is 2 omega and omega with respect to t is d omega by dt. However, 2 cancels in both the terms and leaving the terms such as c theta d theta by dt plus second term is I into omega d omega by dt and differentiation of constant is however 0. Therefore, the total value of this expression is c theta d theta by dt plus I omega d omega by dt is equal to 0. However, d theta by dt refers to as omega and is called angular velocity of the system. However, d omega by dt is called angular acceleration, and this can be written as d by dt of omega, that is equal to d by dt of omega is d theta by dt, that is equal to d square theta by dt square. Then we can write this expression further as c theta d theta by dt, this remains same, plus I into omega. In place of omega, we take that value as d theta by dt, and in place of d omega by dt, we take that value as d square theta by dt square, which is said to be second order derivative of the function, that is equal to 0. Or if we take d theta by dt as common, then c theta plus I d square theta by dt square is equal to 0. But in this expression, either d theta by dt must be 0 or c theta plus I d square theta by dt square must be 0. However, d theta by dt, the angular velocity, which cannot be 0 always. Therefore, c theta plus I d square theta by dt square may be 0. Then if this component happens to be 0, then d square theta by dt square is given by minus c by I into theta. Now, if you substitute this value, which is nothing but angular acceleration, that is given by minus c by I into theta, where negative sign indicates that angular acceleration happens to be in opposite direction. Then whenever the oscillations that are being produced by the torsional pendulum, these oscillations produced are simple harmonic in nature and is said to be simple harmonic motion. For the simple harmonic motion, the period of oscillation is given by t, that is equal to 2 pi root of displacement by angular acceleration. T is equal to 2 pi into square root of the displacement is nothing but theta divided by acceleration is given by c by I into theta, or t is equal to 2 pi root of I divided by c, where c is the twisting couple and twisting couple is given by, as we have observed in the last class about only the twisting couple, where we have obtained that expression for the twisting couple as pi n theta r to the power of 4 by 2l. However, this value of theta is 1 and it can be written as pi n r to the power of 4 by 2l, which is nothing but twisting couple. Now, on account of substitution of this value of c, then we get t is equal to 2 pi root of I divided by c. In place of c, we have to take pi n r to the power of 4 by 2i, or t is equal to 2 pi into root of 2Li divided by pi n r to the power of 4. Now on squaring on both sides, we get t square is equal to 4 pi square into 2Li by n pi r to the power of 4. Or in other words, n is equal to 8 pi square it has to be. 8 pi square IL divided by pi r to the power of 4 t square. That is expressed in Newton per meter square, where I is called as the moment of inertia. This is called moment of inertia. Therefore, the final expression for n is given by 8 pi square IL divided by pi r to the power of 4 by pi r to the power of 4 t square, Newton per meter square, which happens to be an expression for n and is said to be the torsional stress and the deformation that is being produced. Thank you.